started. Okay, everybody, this is where we're at. I'm starting out fast because it's all reviews because I know it's been a week or more. So here we go. Our objective function, 2 variables, 4 constraints. If you recall, if you were going to solve this using the software, you would open up the software, you would say linear programming, you would say okay, you go file new, and it would say how many decision variables, help me out, 2, can barely hear you. How many constraints? 4, thank you. Max or min, that problem? That's normal. Max? Okay, opens up like this. The variables, tell me the variable names on that PowerPoint. DNS for S, which is the first variable though on all these constraints? Where am I? There, right here. S is on the left, D's on the right, just to make it easier. You're going to click here, change this to an S. Click there, change this to a D. The numbers in the objective function I think are 10 and 9. 10 and then 9. I just want you to make sure this is all review. We've looked at this before. I'm going to the first constraint. The number with S is 7/10, and with D is a 1. So this would be 0.7. This would be a 1. Is this a less than equal or greater than equal? Less than equal.
In your constraints?
I don't know if you can or not. But you try it when you get home. Let me know, because I'm still waiting for the Excel spreadsheet where you're putting 2 things next to each other. No asterisk.
I would love to have time to do that, except I have 4 other classes and a job. It's not fun.
The right side is 630. 630. There we go. And you would keep going, and you would do it just like that. And you'd keep going, and it looks like this, right there. Now, to solve it, you click on Solution, Solve. There's our output. This particular output, the software is not rounding, because look at the PowerPoint's output. Go here. See how it has 540 and 252, but the software has 539.9999842, 252.000. That's the only difference. So I want to point out, here's the big difference. Remember I told you, all these softwares in Excel are all giving you the exact same information, but they present it in different ways. And I don't want you to get fooled on this, because on your quiz, you're going to have an output, and you're going to have to analyze it, and on your homework, and on the in-class assignment. So be careful. Now here's what I want to point out. Some of them use upper limit, lower limit, upper limit, lower limit, and the current values in the center. But some of them use the current values on the left, allowable increase instead of upper limit. 10 plus 3.5 is 13.5. Upper limit is 13.5, but is presenting it as the amount it could go up, the amount it could go down, instead of lower limit. You always want to look up here, and this is off to the left here instead of the middle. Same with the constraints. Allowable increase, allowable decrease. I mean, look at this 120 on the second one. 600 plus 120, minus 120. So the most it can go down is, what is that, 480? Second constraint, sure enough, 479.9999. Same number, but it's giving you the lower limit instead of the allowable decrease. So I want to point that out, because if you're kind of going and you're focused on your homework and you're solving it a certain way, this is a common mistake. They won't realize that we're so used to these upper and lower limits, they won't realize it's allowable increase and decrease, and all of a sudden I'm starting seeing that 3.5 is the current value, and you're calculating from there. And so I just want to point that out, because it's a common mistake if you're not looking at the headings. Everybody feel like they could put something in a software. Let me get back here. You can enter the data. Once you have the objective function and constraints, you can set this up. You see the logic behind how to set it up, right? All right, let's go to Excel. Same problem. on the PowerPoint. Everything's the same, 7/10 on that first constraint, 1D, less than equal to 600. This is area up here is just entering the information from your objective function and your constraints. These are the numbers. This is with S. This is with D. If you look at the constraint, this is with S and with D. And then if you go to the objective function, the 10 is with the S, the 9 is with the D. There's no number here because you never put the objective function less than equal, greater than equal, or equal to anything. Here, these two cells are always nothing in there but 0 to start out with, because that's where you want to place your optimal solution. Now, if I were doing this, I would use all these that I'm posting as templates and just start making changes to it. Get rid of columns or get rid of rows. But you can do this any way you want. You can put these two up here if you want to. As long as you're referring to wherever you place all these things, as long as you're referring to them correctly in these equations here and here. This is the tough part. This is the part you got to start saying, do you understand the logic, how this is equations entered and these equations are entered? But here's my hint. Every one of these equations have to use the optimal values, which will be here. So every one of these equations are going to have these two cell locations involved in the equation. Everything's based on S and D. So E16 and F16 should be part of every one of these equations. And once you understand that, you just set it up. E16 times whatever number you're going to use, depending on which equation you're doing. F16 times whatever number, you add them together, or whatever the constraints were. So, let's go back to this. I'm going to pick, I'm just going to pick the objective function. I know this is E, was it 16? Help me out. 16 or 17? Well, where are the optimal solutions on the spreadsheet? There it is. Anyway, whatever number is assumed is 16%. This is going to be E16. That's going to be F16. Now you just got to find the cell location for the 10 and 9. That's how you write the equation. Here's this one. This is going to be E16. That's F16. You find the cell location now where the 7/10 and the 1 is. And that's how you write those equations. That's the logic behind it. And notice some people were having troubles a little bit. So, is it 16? It is. I was lucky. See E16 and F16? Going to be in every equation. Now, this is the objective function, so I'm finding the cell locations where the numbers for the objective function are. And this is E11, F11. So you see E16 times E11, F16 times E11, or F11. Down here, same exact thing. This is going to have E16, F16 in it. Every one of these do. But all you see changing now are the cell locations where the numbers are put. E7 and F7 are right there with constraint 1. E8 and F8, right there with constraint 2. And E9, F9, E10, F10. But every one of them is referring to wherever you're placing your cell locations where you're going to have the optimal solution show up. So this is how they're written. And you know there's a good possibility there's going to be a picture of a spreadsheet. And I'm going to say, what is in, if I were to click on cell E22, what would I see? What would be written there? What's the equation using cell locations? And we got to get to a point where you got to know if you want to use dollar signs or not. Maybe not use choice, but we got to get to that point. And sure enough, your answer should say equals E8 asterisk E16 plus F8 asterisk F16. That would be your answer on the quiz. Exactly what should be there. And you know on the last quiz, we kind of did this, and I hope you realize I'm going to make sure that the answer is not the exact answer from the templates you're using to help you, but it's all about you looking at this template to figure out the logic and then apply it to the picture that's on the quiz. All right? So that's how these are done. When you solve it here, some of you, if you're doing it at home, you may not have, I'm going data, solver there. So get on the internet and say, you know, I don't have solver. How do I install solver on Excel? And you'll see so many web pages that says, go to file, go to add-ons, or whatever it says. It would step-by-step take you through getting solver on there if you don't have it. If you don't want to go through that, Lab Anywhere will connect you to a lab computer, and that will probably already have solver on it. And you can just have that be your computer. If your internet's fast enough, it will be like you're on your own computer. It's fast. So you have choices. I have some looks. that some of you've never heard of Lab Anywhere. Should I go deeper into Lab Anywhere? Raise your hand if you want to hear more about it. You've never heard of it? I don't have the website ready, but it's just like looking for student services. You go and put Lab Anywhere, gives you a link. And when you click on it, it will ask you, do you want to install something or just go make it look like a web page? And all of a sudden you say HTML, and you give it some time, and you see this little start button right here? When it loads, you'll see a second start button right there, because now you're looking at a lab computer screen like you're sitting right at the lab in your home. And everything that's on the lab computers are now accessible to you just by clicking on the start, picking one of the apps, and use it. So that's available to everybody. Before this year, before they switched over to 10, Windows 10, the management scientist was there, so it made it real easy for people to use, because they'll just click on Lab Anywhere and play with it there, and not have to install it on their home computer. If I remember, I'll bring the web page link to Lab Anywhere and demonstrate how to do it. It's real easy. It's pretty self-explanatory. How do we solve this? Are you ready? You could have a picture of the solver. And the question may be, this will all be out of here, these won't be here, or that won't. And it may say, what would you enter right here? Where it says by changing variable cells. Hopefully you put in your notes, oh, that's the location where you want the optimal values put. You find those cells, and that would be your answer for that one, the cell locations. This is all reviewed. I entered this all in here, but look what's happening. At the top, the cell location where the objective function is located. I clicked on a max because it's a maximization problem. Then I put the cell locations where the optimal solution, optimal values are going to be placed. Then the constraints. And all I did was I would say, yes, I want to add a constraint. It says where cell reference means where's the left side of the constraint equation. And I'm going to say right here at E22. Then you pull this down, you want to use equal, greater than equal, or less than equal. It happens to be a less than equal, so we'll put that there. And then the constraint, this is where you tell the cell location where the right side of that constraint is. So E22, the right side would be right there at H22. And then I would just click OK, and all of a sudden that would appear there, but this constraint's there already, so I'm not going to click OK. But if I did, click OK, see what happens. It'll say this constraint's already there, I think. I added it again. Where is it? So see how there's two E22s less than equal to H22s. You get rid of one. There we go.
Does it do anything that have multiple?
Yeah, I don't know. That's weird. I should have ran it. I clicked on make off unconstrained variables non-negative. You got to click that box. You open this pull down. If this is the first time you're using it, it will be on this default right here. You will not get the right answer. Move it down. We're using the simplex method, it used to be called. It's a stepping stone method that we all used to have to do by hand because I'm so old there were no computers. That's the truth. So simplex, right there, click solve, and there's two things. I don't want just your answer. You're getting to a point now where you're going to have to hand in a spreadsheet showing me that you can solve it using it. So I want to make sure you get both forms. So when you hit OK, it goes really fast. There it is. Click on, you want the answer and the sensitivity reports. Answer and the sensitivity reports. Now I'm going to click OK, and right down here, two more tabs will open up. There they are. Here's the optimal solution, right in E16, F16, just like we planned, 540 and 252, just like the outputs. And down here, on this page, it's set up to where you can see, like, for example, all the spreadsheets I posted, I think this is the only one that I hand wrote an if statement here. So you can use it if you want, but most of the spreadsheets won't have that. So I'm just kind of covering this up. But you can just look at this and say, oh, look at this. This one, all the resources being used. There's zero slack. Notice I'm using the word slack because of that. Or 8600. Oh, here we have some slack. 708, 708. Matter of fact, I can look at this 630, 630, 708, 708, and I know I just located binding constraints. Because when all the resources are used, and the left side and the right side equal each other, there's no slack or surplus depending on what was less or greater than. And that's a binding constraint. You may see a picture of this, and I may say, on all you can see is this. And I may say, which constraints are binding? You've got to realize, oh, it's the ones that have equal left and right, meaning there's no slack or surplus, and if it's a greater than this. But here, it will give you some more information. For example, this Excel presents the upper and lower limits like that other software as allowable increase and allowable decrease. So you kind of got to get used to this one, just like I pointed out before. This one, where is it? Here's the right-hand sides, and here's your final values. 630, 630, there's a binding constraint. 480, yeah, around that. 600, oh, we have something going on here, either slack or surplus. We got to try to remember what the original constraints are. 708, 708, binding constraint. 117, 135. But you go over here to the annual report, roll this down, and right here, slack 120, constraint 2, slack 18, constraint 4. So you can find it right there.
Would it have a surplus if there was?
You know, I can't remember. I actually, when I was quickly putting this together this morning, because I hadn't seen this lecture in a long time and I'd just been swamped, but I started thinking to myself, there's a chance that this may say slack no matter what, but I can't remember. And so you got to not count on that. You need to look back and see if it's a less than equal or a greater than equal, and let me, because you're going to have to put on the quiz or on your homework whether it's slack or surplus. So don't rely on that. Look back and see, is it less than or greater than? Just review. Less than is slack. Greater than is surplus. That's all you look at to determine slack or surplus. It doesn't matter if the left side and right side are not equal. Find the difference, absolute value, no negative, and then add the word slack or surplus based on whether it's a less than or a greater. All right, what else do I want to find? Do we, can you guys, I feel confident you can enter all this data. And I'm starting to feel confident that you probably could do these formulas, right? But I want to make sure I feel confident that you would know how to enter everything into the solver. I believe there's a page in your book that gives a really good example on how to enter into solver, but I didn't write the page down. I know it's somewhere in chapter 3, somewhere in there. It could be at the end after the problems on chapter 3 or something like that. But I had the page number on here and I had to take it off because I looked at that page and it wasn't there. You have time to search for it. Oh, look at this, objective function values here, but if you had an output, let's say computer output, like you just solve again, it's way up here at the top. And other softwares have it in different places. The book, or I mean the PowerPoint, also has it up here at the top, right there. All right. Now, ready for some more review? If a change takes place with the numbers in the objective function called the coefficients, the 10 and the 9, the change that you're going to be asked about is going to start with asking, are the optimal values for these variables still valid? Anytime there's changes in the objective function numbers, it's all about the optimal values of the variables, and if they're still valid. Students sometimes will mix that up with, oh, there's a change in the right-hand side. Or they'll have a change here within the objective function, and they'll start using the dual price to calculate the new objective function value. But the dual price and changes in the objective function have nothing to do with each other. You should not, that's an accident. You should never combine those. Everything about the right-hand side changes are all about these dual prices. And most of the time, if these are changing, these are going to change no matter what, but you're not going to be asked about that. The decisions that need to be made in real business, if something's happening here, it's all about how is this going to affect our objective. If we're trying to max something or if we're trying to minimize cost. It's all, the decision on these changes are all about these dual prices and the effect it's going to have up there on that objective function value. That's the connection. So somewhere, changes with right-hand side constraints, all about dual values or dual prices. They all use different names. I need to point that out. And that's what you would use to calculate the new objective function value. Any changes in the objective function numbers is all about the optimal values for the variables, And that's what you're going to use to calculate the new objective function value. You're using those with an objective function, you're using these if it's constraints. Now, if the question's asking about one change, you just look to see if it's in its limits. If it is in its limits, you do the math to get the new objective function value. Your quiz and your homework is going to ask about two changes or more. And anytime there's more than one change, you must calculate the 100% rule. How far did we get on the 100% rule last week? We didn't. So now I'm here. I'm at past review. All right. 100% rule. The first one, I want to go. I got a page number here. Page or slide 14. I'm going. This kind of talks about. Here's the first one. No. Here we go. There's the 100% rule. Let me get to an output. Look, I'm mixing up outputs on purpose. I want you to get familiar with all of them. Going to this output. You ready? Look at this old output. Upper and lower limits. Hey, we're about to start manufacturing of these standard and deluxe bags. Currently, in our meetings, we all came up with, finance said for sure it's about $10 profit for each standard bag, about $9 for each deluxe bag. And we were about to get going, and all of a sudden we just found out, hey, we are making more money on the deluxe bag than what we calculated. We're not going to make just $9. We're actually going to make 11. 9 is going to 11. And we also miscalculated the standard bag. We're not going to be making $10 profit on each one of those. Instead, we're only going to make $9 profit. 10 is going to 9. All right. Step 1. You must look to see if each change is within its limits. You put a quick sentence down. Both changes are in their upper and lower limit, or however you want to word it. Both changes are within the range of optimality, or you can be specific. Here's specific. For variable S, I'm going to put S here. S and D. For variable S, sorry, going backwards. Hang on. I did this one first. For variable D, it's currently $9, but it's going up to 11. The upper limit, or it will say allowable increase. You got to work that out. Is the upper limit is 14.28 whatever. It's going to 11. 11 is within that upper 14 whatever, right? I lost anybody? Am I still here? We're okay? Okay. I feel like I lost some people. 9 is going to 11. It's within the upper limit. Limit. Whatever you're going to write there. Look at the next one. 10 is going to 9. The lower limit is 6.3, or allowable decrease. You can compare it, it's going 10 to 9. That's 1 unit. The allowable decrease is blank units. You can do it that way. Since the lower limit is 6.3 and it's going down to 9, it's within its limit. Okay, check. Step 1's done. Step 2, you're saying, is there more than one change taking place? Do I need to calculate the 100% rule? Yes. There are 2 changes taking place called simultaneous changes. So you must do the 100% rule. You can't rely on just if they're in their limits. There are many times that all the changes, and there's like 3 going at the same time, or 4, that they're all within their limits. But when you do the 100% rule, because of the amount of changes that are taking place, if it goes over 100%, you know, these, what are we on this? These are no longer valid. And you can't come up with the new objective function value. But I want to protect you from making an awful mistake. If the new objective function value is being asked for, and your 100% rule says you don't need to calculate it, do not trust yourself. Calculate it. You will lose so many points leaving the new objective function, not calculating it because it's over the 100% rule, and you accidentally made a math error to make it over the 100% rule. The amount of points you're going to lose for not doing the new objective function value is you just killed your grade. I mean, there's nothing there. So my advice is, no matter whether you think you should do the new objective function value or not, do it. Do the new objective function value, no matter what. You can't afford to lose those points. So now, we have these 2 changes. Here's the 100% rule. 9's going to 11. That's 2. 9 could go all the way to 14.2857. That's 5.28, whatever it is. So 2 divided by 5 point, I need to round a little here. 2, let's make it 3. Right? Wait, no, what is it? Am I looking at the right one? Yeah, 5.3, right? It's currently 9. It could go all the way up to 14.3. So it's at 5.3, right? Okay, give me a percent there in a minute. The other one, going from 10 to 9, that's 1 unit. It's going from 10 to 9 in this direction, not this whole range, just the direction the change is going in. That's 3.7. That could go. 3.7. So here I'm at about 30%. Help me out. 1 divided by 3.7. 0.29, what is it? No calculators. It's stay Tuesday. Thank you.
No, it's Tuesday.
Okay, you guys stop. He's joking. 2.5.8. 2 divided by 5.3. Give me a number. Point what? Point?
3.8.
0.38?
Yeah, 377
Wait a minute.
3.377 by rounded.
Thank you. I'll do it too. Sounds good. 1 divided by 3.7. 0.28? 0.27? 0.27. I add these up. 50, 65, 0.65. You must show that you're comparing this to 100%. You've got to show me. This is less than 100%. 0.65 is 65%. So it is less than the optimal values for the variables are still valid. You've now proven it. They're within their limits. 100% rule. Now it.
Where did the 2 on the 1 come from?
This one is because this was going from 10 to 9, which is only 1 unit.
Okay.
This,
Got it.
you got that part. New objective function value will be the next question, without a doubt. All right? It'll say, it'll say, in fact, to try to help you not lose points, it will probably say, no matter whether you said if the optimal values are still valid or not, calculate the new objective function value. Now here's where you go, whether you say to yourself, should I use these dual prices or not? Is it called dual prices here? Dual prices or not? Should I use them or not? And this is where you got to catch yourself and go, the changes are taking place in the objective function, so I'm not supposed to use the dual prices at all. I'm supposed to use the optimal values. So up here, the optimal values are, S is 540, so S is 540, D is 252. Now there's 2 ways of doing this. You can take whatever the new values are, the 11 and 9, and multiply them by the appropriate numbers, add them together. Or you can take the amount of change. This one's going up 2 units times 2 added. This one's going down 1 unit times 1, is this S? Yeah. Times 1, subtracted. You decide whether to add or subtract. When it comes to the objective function numbers, you decide whether to add or subtract based on whether the change is increasing or decreasing. That's how you decide on this section. It's much different down here how to decide whether to add or subtract. But here's easy. If D is increasing, like it is, we're adding. So, you ready? This is increasing by 2 units. I'm putting a big plus there, so I remember to add. This 540 is S. S is decreasing. It's decreasing by 1 unit, so 1 unit minus, because it's decreasing. The current one is 7668, so I'm going 7668. I'm adding, and 252 to 504. I'm subtracting 540, so this is added, and this is subtracting 7. I've lost some people. You ready? Let's go back. Hang on, almost there. This, after 31 years, you're talking to me when my back's turned. I'm just hypersensitive to all nonverbal communications. You're all over. What? You're not here? I know that. You ready? You ready? Currently is 7668. There's a 2 unit change taking place with D. The optimal values are still valid, so the 2-unit change times the corresponding optimal value, 252 at the top. Since the change is going up, we know to add that. So I'm going to add 504 to 7668. This one is 1-unit change. It's going from 10 to 9 down. Its corresponding optimal value is still valid also, 540. I multiply that, and I'm subtracting because it's going down. And then this ends up being, give it to me.
-36. Well, -36 is 504 minus 540.
Yeah, so you subtract 36, you get 76, 32. So 7668 plus the 504 minus the 540 equals 7632. If anybody, I'm going to jump into that. If anybody found this difficult, some people find this easier. You ready? I'm going to put it in the order up there. S happens to right now be 540. D right now is 252. That optimal value up there, 7668, is calculated by the current value 10 times its optimal value 540. Current value 9 times its absolute optimal value 252. Added together, that's how you get 7668. So instead of using 10 and 9, we're going to do the same math. We're going to use whatever they each turn into. The 10 went down to 9. So I multiply this by 9, because that's the D. That's the S. All right. You ready? Go back here. The S, 10 went down to 9. So instead of multiplying it by 10, I'll use 9. Geez, did I do it again? Seriously? Wow. The D is going from 9 to 11, so instead of using 9 on the 252, I'm using 11. Now I want to tell you something. If I take 9 times 540, 11 times 252, I know it's going to equal 7632. It's just another way of calculating using what they changed into times the optimal values. Now everything you just saw, 100% rule.
Yeah.
Everything you just saw is all about when the objective function has changes. Everything you just saw. Now, we're shifting gears. It's all about what happens if the right-hand side of constraints have changes. So we're shifting gears.
Why wouldn't, if we just put 9 and 11 into like the Excel formula, like...
Yeah, that's right. If you had the Excel formula, but to show your work, you'd have to send it to me. But you guys, what he's saying is, can you go right here and change that to S went to 9? Let's see what happens.
Yeah.
And the 9 went to 11. And what he's saying is, will that come out to 7632? Here we go. Look at that, 7632. So you can use that to check your answer. But on a quiz, you can either write this like this, and then use that to check your answer. But if you use this on the quiz just to do that, by changing those, bring it to my attention at the end of the quiz so we can figure out if I need you to email it to me. Okay, but yeah, you can do that. All right, here we go. We're going to look at a different output, so you can just so we start to get used to the different ways these look. I want to point something out. Where'd it go? This output, I want to point out, says dual prices, right? But look at this. We go to, is this it? Where'd it go? Where'd it go? Right here. Excel doesn't call them dual prices or dual values. They call them shadow price. $4, 37.5 cents, $6.94. It's called shadow price on here. And what was the other one here? The other one, is this it? No, it's dual prices. Where's the PowerPoint? 21. Look at what's called here. Dual values. So now you see the exact same thing being called 3 different ways. Dual prices, dual values, shadow price. There's like 4 other ways. They're all giving you the exact same information, different titles, different presentation of it.
What does the dual value or the dual price represent?
This right here?
Yeah.
Forget reduced cost. If I had not canceled that one class, we'd start getting into it, but it's usually the last thing I teach. Focus, so I will not put that on a quiz, or on your homework. But dual value is if there's a change in the right-hand side of the constraints, just like dual price, just like shadow value. Is it shadow price or shadow value? Price, just like shadow price. And there's someone out there who probably does call it shadow value. You know, there's all these different names for it, but they're all the exact same thing. We're going to use this one with the dual value this time. Same, and you're going to get the same numbers. It's just being presented. Now you're seeing allowable increases, allowable decreases instead of lower and upper limits. The right-hand side of, let's see, I don't know, of the, I'm going to make sure I get this, first constraint has 10 more units got dropped off. That's, whatever that resource is, I know it's hours, but let's say it's steel or something. 10 more units are there. And we're going to have to pay for them because we accepted them at the dock. Can we use them? How's this going to affect if we put these 10 more units of that first constraint into the manufacturing process? To make a quick answer to that, we look to see if the change is within the limits. Because there's only one change taking place, so you don't have to do the 100% rule. If 630 is going up 10 to 640, is it within its limit or allowable increase? Yes or no? Yes. What number are you looking at to compare these 10 unit increase to? What number? 52. There it is. 630 is going up 10 units, so you compare it to allowable increase. It could go up 52 units. If we look at a different output, the upper limit would be these two add together, 682 point something. But you've got another one to look at the upper limit. So 10 unit increase is within the allowable increase. So that means that $4.37.5 valid. We can make a quick decision. Now here's the tough part. Where's my pen? To figure out whether you add this or subtract it to the objective function value, it's based in this order. 1, changes within the limits. I'm going fast because these first two are repeats. 2, if there's more than one change taking place, do the 100% rule. 3, right, is the dual price or shadow price or dual value positive or negative? In this case, is it positive or negative for constraint 1? I hear positive, is that correct? Everyone agree? It's a positive 4.375 dual price. If it's a positive number there on that output, it's trying to tell you, hey, if that corresponding constraint increases 1 unit, it's going to have a positive effect on the objective function value by $4.37.5. In our case, it went up 10 units. So if it goes up 10 units, you multiply that times $4.37.5, and you get $43.75 change. You with me? So we calculate the change. We notice that it's a positive dual price. We know it's supposed to have a positive effect if it's increasing by 1 unit or more, a positive effect. The next step, you got to say to yourself, is this a maximization problem or a minimization problem output? It will always be given to you somewhere on there. And if it's a max, since it went up and has a positive effect, you need to add it. Because max is probably profit or something good as a manager's point of view. And by increasing it would be a positive effect. So you would add it. And if it's a minimization problem, the positive effect would not be added. You subtract. So right now, nothing's changed. It's 10 units up. We multiply 10 times that because the change was within its limit or allowable increase. And so we took 10 times the amount of the dual price. And this amount either has to be added or subtracted. The last step, you go and search, minimize or max. And I would have a little box right there. If it's a positive effect and it's a max, add. If it's a positive effect, it's a min, subtract. And then you know whether to add or subtract. Now, let's pretend that it didn't increase by 10 units, that this decreased by 10 units, that only 620 got delivered. The company didn't call us, our supplier, and say, hey, I'm going to short you 10. It's a shock to us. And we're about to start production. And we need to know how this is going to affect the bottom line, the objective function. is $10 less units. Can you tell me if the dual price or dual value or shadow price is still valid? Yes or no? Yes. Why, Matt? Hit me. This is going down 10, but what? What are you comparing it to? The allowable decrease, 134. It could go down 134 units, whatever that lower limit is. Since it's only going down 10, step 1 is within the allowable decrease. Now, we look up at the dual price. This is valid. Look at that. It's a positive effect if the change was going up. But this change is going down 10 units. So you've got to go with the logic, it's going to have a negative effect. And then you go to look at your, then you go, okay, now you go, now I know whatever I'm calculating, 10 times $4.37.5 is going to have a negative effect. Then you start searching, max or min, max or min. If it's a maximization problem, and you want a negative effect, and on your little chart here, maximization, negative effect, you subtract 10 times $4.37.5, subtract it from the current objective function. If this is a minimization problem, and you're supposed to have a negative effect, you need to add $43.75. Do you see the difference? Because if it's a minimization problem, that probably represents cost or something that you want as low as possible. So a negative effect would be adding. So that would be my 4 boxes. Positive effect, maximization, add. Minimization, subtract. Positive or negative effect, maximization problem. What did I say? Negative effect, subtract. Minimization problem, add. And that will steer you in the right direction, and you follow that order, and the last thing you're looking for is whether it's a max or a min, go to that box, and then decide to add or subtract. Do not rely on whether this is positive or negative. Oh, if this is negative, I would have subtracted. If this were negative, I would have added, or something like that. You rely on the logical steps that get you to that point of deciding whether you should add or subtract. That's what it's about.
Okay, so what is the number become now that we've decided we're going to add $43.75?
Are we adding it? We're going back to this, went up by 10.
Yep.
Positive effect, max problem, add it. So 7,668, 7,668 plus 43.75 is your new objective function value in this problem. Whatever it was, you come to the conclusion you're adding for the positive effect. You add that plus the change, and you got your new value. You're showing me the work. Okay, go ahead.
Like recapping that real quick, what does 5.3 represent? Is that the allowable increase?
I gotta find it.
Top right.
This is the amount, yes, the amount on the objective function. This is the amount it could have increased. We're right here. Was that an S or a D we were just looking at? There it is, allowable increase 5.2857. So it's always the amount of the change divided by the amount it could change in the same direction. In this case, this was increasing, so we compared it to the allowable increase. But if this is decreasing, we've got to compare it to allowable decrease. And that's why we're dividing. 100% rule for right-hand-sided constraints now. It's almost exactly the same 100% rule for the range, for the optimal, for the objective function. Almost the same exact rule. If there's more than one change taking place on a right-hand-sided constraint, you look for the limits, and because there's more than one change, you must do the 100% rule. Here we go. 630 was going up to, by 10, you go to 640. The other constraint, 3, which is currently at 708, okay, hang on, make this challenging. I got to stare at it for a second. Going down, it's going down by 80. So that's 628, is that correct? All right, there we go. Step 1. What's step 1? I can't remember. I remember, come on.
Check the limits.
Check the limits, thank you. 630 is going up 10, 640, 630, oh, they don't have an upper limit, but it's going up 10 compared to 52. Check. I write down within limit. 708 is going down to 628, that's 80 units. Allowable decrease, here it is. Could go down 128 units, it's going down 80 units. It's within the limit. Check, check. More than one change taking place, it's time to do the 100% rule. This amount is 10. It's going up. The amount it could go up, let me go back here, gives it to you. You don't even have to figure it out. It's right there. 52 point, is that 38 or 36? I forget already. 52?
Yeah.
52.3, what's the next digit? Round it for me. Is
4.
it still 6? No matter what? There we go. So 10 divided by the amount it could go in that direction. This one's going down 80 units. The amount it could go down is 128. There it is. 10 divided by 52, that's going to be, that's about 18? 19.19? Okay, this one's going down 80, 80 divided by that here, that's about 60.6 something? 625. I'm going to add these up, 0.19 plus 0.625. I'm going to make that 20, so I'm at 0.815, I think. Yes. Is that less than 100%? Yes or no?
Yes.
Sure enough, I'm showing that I'm comparing it to 100%, 81.5%, if you want to turn to a percentage, is lower than 100%. Therefore, what's still valid? The blanks are still valid. Fill in that blank for me. That old one. Not the optimal values. If we were talking about these objective function, that would be correct. Not the binding constraints, not the solution. Oh my God.
Yep.
I'm walking out of here. I'm leaving. I'm leaving. Seriously. What's still valid now that we did the 100% rule?
Yeah, no bad.
Not the optimal values. Some are whispering the right answer, but I can barely hear it, so. Say it again? No. No. Wait a minute. Stop. We're looking if they're within their limits to prove something's valid. We're doing the 100% rule to prove something's still valid so we can make calculations. If we were talking about the objective function, it's all about if these are still valid, the optimal values. But when we're talking about the right-hand side of constraints, it's all hippie. The dual values, or the dual prices, or the shadow value. That's what we're deciding whether they're valid or not, so we can get that new objective function value. That's what this whole thing's about that we just did. We now state that the dual whatever, shadow, dual, whatever you want to put there, whatever it says on your output, are still valid. Now that we know they're still valid, but by the way, like if this were 10 points, 4, 4, 1, 1. So yeah, you've got to state this. This is 1 point. These are all 10 points right here. Now it's going to say whether the dual values are still valid or not. Calculate the new objective function values. Now here we go. Here's the order. We already know they're valid. The first constraint is changing 10 units. 10 times its corresponding dual value, which is 4.375. There's that part, which equals 4375. The next change, 80 units times its corresponding dual value, which is that 6.93? Is that what that is? I'm going to round it to 4. 6.94, just save time. Which equals, now this I need help on. 80 times that's 140 something, 104, no, that's way more. What am I thinking? That's 480. Say it one more time.
55.2.
Is that right? Is that what you got too? Where am I? 5, a third 5.2, right?
Yep.
Okay. Here's our two values. Now here's the part I want to make sure I got everyone's attention, because this is where, no matter how much attention I can get your focus right now, a bunch of people are going to blow this part, because this is I haven't been able to get through a semester yet where this part doesn't get blown. Are you ready? How we doing? Damn. You ready? To decide whether we add or subtract, starting at our current value of 7668, it's all about you looking at, is the dual price positive or negative? Is the change going up or down? Is this a max or a min? You ready? The first one is a 10. Is the dual price positive or negative up there? It's a positive. If that constraint's going up, it means positive effect. What's happening? Going up. I'm going to put the word positive effect here. So I remember that's a positive effect on that one. because it's going up and it was a positive dual price. The second one, the 708 is lined up with 6.9375. It's a positive 6, not a negative. So it means if that constraint's increasing, positive effect, I look back here, oh, it's decreasing. So it's got to have the opposite effect, which is a negative effect. So now I got my effects. Next step, I go to look at this is a max or a min. And I'm looking, and sure enough, right there, it says the output above is for a maximization problem. Positive effect, we add or subtract if this is a max. Negative effect, if this is a max, subtract. The first one's getting added, the second one's getting subtract, all because we're going step by step to try to figure out which way we should add or subtract in that order. And the last step, I want to remind you, is this a max or a min I'm looking at? That's what decides whether you add or subtract. That's the decision. So what is it now? 7668, 7668 plus 4375 minus 555.2 equals, Jack was all over it a minute ago. Anybody else? Nay. No apologies necessary. Wait, is that right? Is it? It should be higher, should be higher. No, I'm sorry, wait a minute, wait a minute, stop. Yeah, 7,000 something. 7668 plus 43.6. There we go, 7456.
71.
Thank you. 7,156 is my new objective function value because I started at the one that's at the top of the output. I did a positive effect, or I added this one because it's a max problem. It's supposed to have a positive effect. Negative effect on a max problem, I subtracted this. This one's a lot bigger than that, so I knew it had to be lower than 7668, and it's 7156. All right, that's the hardest part. We're past the hard part. What I've done with these concepts is, my whole thing is, I always take these and I go, how do I break them down so small that I want everybody to understand? Even those, I break them into little bitsy pieces so that everybody can see the logic behind every one of these, whether you're a person who likes math or not. The problem is that there's some people that this is so easy for them because I'm breaking it down so small that they're going to start not feeling challenged, and this class is going to be boring for them a little bit. Go ahead.
Would I have done my math differently, and if so, if it was a min problem
Yeah.
rather than a max? Can you
Positive effect on a min would be subtracting. A negative effect on a min would be adding. So this number would be bigger than 7668 if it were a minimization. So it's all about the effect, and whether it's a max or a min, to decide if you add or subtract. You've got to go in that logical step. The biggest mistake is I have a whole bunch of people that add just because, oh, it was a positive dual price, I'm adding. But that's not the right logic.
How do you know if the problem is in a math?
It will always be given to you in the words. I'm just going to quickly show you your homework. This is due Thursday, so you don't have as much time as usual. But if you look at this homework right here, look at where at the very top, right below it, look at the sentence it has. It says minimization problem output above, and that will be just like a quiz. It will say something like that somewhere on there. Okay. And then we've got one more thing to cover before we get started. 1 minute. No, you only need about 12 minutes. So I got about 3-4 minutes to cover. One more thing.
Shave 3 minutes off like that?
You old? You ready? I can't remember the slide number. 28. Okay. Sunk cost, relevant cost. Let me repeat these. Sunk cost, relevant cost. Sometimes companies will have, let me get to the output. Everybody got the 2 words? Relevant cost, sunk cost. Everybody got them? Okay, let me get back to the output. 21. Companies sometimes will have this objective function right here. Everything built in, every single cost, including the overhead and everything, will be represented in those numbers. And some companies leave the overhead off, or different things. And so when you hear on a quiz, I will always tell you whether It's a sunk cost you're about to read about or a relevant cost. Now, here's the deal. A question is going to be about one of these resources. And it's going to say the supplier for the 630 called and offered, we're going to stick to like the old example, 10 units. Remember we were going up 10 units, they dropped off 10 too many? In this case, they didn't drop off 10 too many. We got called the next day after they dropped the load and said, we have 10 more units. Would you like them? Do you want them? And as a matter of fact, we have these 10 more units. I'm on constraint 1, right here. Here it is, right here. Okay? I'm on constraint 1. It's going up 10 units. And here's what they're telling you, and this is very common. I need to know right now. You know, I'm being told that this has to be dropped off somewhere by the end of the day, and if you can't answer me right now, I'm going to the next client and offering them the same deal. And the deal they offered us is they said, you can have these 10 units for $50.
No.
Wait, stop. You can have these 10 units for $50, but we need to know now. You don't have time to run this program over and try to figure it all out. All you need to know is that, is this thing representing a sunk cost or relevant cost? Now here's the deal. If the problem says, and constraint 1's right-hand side, the amount and the whatever the objective function are a sunk cost. Everybody hear this? S-U-N-K means that the dual price represents the most you would want to ever pay for one more unit. Everybody hear that? Let me say it again. If it's a sunk cost, the dual price represents the most you would ever want to pay for one additional unit. We're being offered 5 additional units. Step 1. Check to see if these 5 units are within the upper limit or the allowable increase. Because if it's not, you're looking at a dual price. That means nothing. It's got to be within the limits to rely on that dual price. So are these 10 units within the upper limit? Yes or no?
Yes.
So the dual price is accurate. We got offered 10 units. They need to know right now. You don't even have time to check with the supervisor. It's on your shoulders. Do you say yes or no? I'll take it. Yes or no? Who said yes? Who else? No, stop. Stop. You got offered to pay $50, but how much of these 10 units going to affect your bottom line, your objective function value? 10 times 4.375 is $43.75. If you pay them $50, you're coming out ahead 43. You just lost $7 and your job. All right, because these are all in thousands. So you just lost your job. You get it? You ready? This is a sunk cost. It's a sunk cost. The supplier for constraint 3, which we're at 708 right now, just called and offered us 10 more units. 10 more units for $59. Constraint 3, and it's a sunk cost. Everybody with me? Constraint 3 just called, offered us 10 units, $59. Yes or no? Yeah, I saw that one. I heard it. Bailey, say it again.
Yes.
Why?
Because the dual price is 6 something.
That's right, 10 times that. The most we'd ever want to pay is $69.37. It's being offered for $59. We're coming out 10 ahead. We don't have time for relevant costs. So we're going to face relevant costs. And thank God, because your question on the homework is about sunk cost. God, I hope.
Relevant cost.
Oh!
You got it covered.
Oh! Backup plan, sign-in sheet, no in-class sign-in, backup plan. Oh!
Why don't you just change it?
Where did that celebration come from?
Why do you
Wait a minute. Let me make one thing clear. The in-class assignments, this class is designed where the in-class assignments help you keep your grade up.
Wait, why wouldn't you just change the word from relevant to something?
I could. You want to do that and have an in-class? Is that what you want to do? Let's vote. I can change that word to sunk. We have an in-class. Would you rather have that? Raise your hand so I can see. Oh, you are outvoted. We're going. You ready? We're going to relevant. Going to relevant. Here we go. Where was that output I was looking at? Was it on the PowerPoint? This is the one we're using. You ready? Same scenario. Same scenario. The supplier just called for constraint 1. We're at 630 units of it, right? They're offering us 10 more units. Hang on, I gotta think about this. They're offering us 10 more units for, what is it, right here, $50? We're gonna stay with that. We're staying right there. Let me review. I want to make sure you get this. Supplier called for the first constraint. We're currently at 630 units. They offered 10 more. Is the dual price still valid, yes or no? Who said that? I didn't hear it. I thought I heard no. Is the dual price still valid? If we take these 5 units, dual price still valid, yes or no? Come on. You ready? The supplier just called. They're offering you 10 more units of this. We got to make a decision right there. Is the 10 more units within, or telling us if the dual price is still valid or not? Yes or no? Yes, because? Because within the level, 10 is within 52. That's check number 1. Number 2 is this a sunk cost or a relevant cost? Does this represent a sunk cost or a relevant cost? Oh, it's relevant. So, if it's relevant, the story, if I read that whole homework problem, is going to tell you the usual price we pay per unit for this resource. It might say, and usually you pay $3 a unit. $3 each is your usual price. Relevant means that the dual price represents the most you would ever want to pay above the normal price. Did everybody hear that? Relevant means, or relevant cost means, the dual price represents the most you'd ever want to pay as a premium above the normal price. Because in real life, like with steel, when there's like a steel shortage going around the country because maybe there's tariffs and not enough steel's coming in, it's sometimes hard to get your hands on steel. And you're willing to pay a premium to get additional steel. That would be a perfect example. And so it'd be maybe the whole output, somehow or another, it's a relevant cost. Because that overhead hasn't been built into these numbers, possibly, is usually the reason. And you're going to see relevant cost, the normal price is $3 a unit. All 10 of them are being offered at $50. We usually pay $3. Look at the dual price. We usually pay $3 a unit. Are we going to take those 10 units at 50, yes or no? Well, I thought I was going to hear some answers.
Yeah.
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 Here's why. 10 more units at $50, we're paying $5 a unit. We usually pay $3, so they're trying to get some money out of us, right? But if we usually pay $3 and it's a relevant cost, we're willing to pay 3 plus 4, 37 a unit is our rule, or we're made a bad decision. So for $3 plus this dual price of 4 is 7 something, and we can get it for 5. We'll take it. Now in real life, I still might let you go because you didn't try to negotiate the price down. Even though we know we're going to take it, always negotiate. Always. That's the golden rule when you're a buyer. Always negotiate. Always negotiate. No matter, you already know you're going to take that, but try to squeeze some more money out. That's your job. Go ahead.
What dictates whether it's a sunk or a relevant cost?
What does it what?
What dictates, what makes it a sunk and
Oh,
what makes it relevant?
it's usually, if originally, like certain things are built into these two numbers. Like finance said, we should be making gross profit of $10 on each standard bag, $9 each less. Gross profit isn't taking those everyone's salaries and all these other expenses into consideration. Sometimes some companies will put these together and have all overhead built into here, and then it's a sunk cost. You just look at the dual price. But if everything's not here, it's a relevant cost, and you got to look at that dual price, and you got to know what do we usually pay for one of these resources. So, you ready? I want to make sure you get this. Resource number 3, constraint 3, 708. The supplier just called and offered 100 more units. 100 of them. Where am I going here? Right here, off camera. 100 units. All right, and and they offered it to us for almost there. $500. $500. $500. But you gotta let us know in 30 seconds, because we gotta go on to the next customer. We gotta do something with it. All right? And it's a relevant cost. And we usually pay $2 a unit. Here we go, let me say it again. It's a relevant cost. We usually pay $2 a unit. We're being offered 100 of them for $500. Go ahead, Bailey, do we take it or not?
Yeah.
He says yes. He's looking at what our usual cost is, and he's looking to see if that change means the dual value is still valid. Is the dual value still valid?
Yeah.
Because why?
It's,
But then allowable increase.
What? That's it.
under.
Yes. Yeah. The allowable increase is 192. Since it's only going up 100, that dual value is still valid. That's the most we want to pay above normal because it's a relevant cost. So I add 693 plus 2 makes 1193 each. 1193 per unit, the most we would ever pay. That's a break even. So we don't even want to break even on this. We want to make money. We wouldn't even say yes to this, I hope. And so this is being offered for $500. How much would that be per unit for these 100 units? $5 each. No, $500 for the whole thing. Not just per unit. The whole 100. So they're asking for only $5 for the whole thing. You're so flabbergasted that you can't believe you're getting this for less than half of the max you'd be willing to pay, and yet you still got to be good at your job, and you're trying to get them down even more than $5. That's real life.
Can you explain why it's $11.93?
Let me check. $2 plus $6.90, and my math's way off.
Yeah,
Wow.
honestly.
Wow, sorry about that. Why do I see the research? There we go. What is it? This is what was it? What? 693?
Yeah.
So this is 993. Okay, so it's
No,
what?
893.
All right. 893. Well, look at this is a harder decision now. Do we take the 100 units relevant cost? Yes or no?
Yeah.
We do take them because they're offering for $5, where our usual price is 2, plus this makes $8.93. So as long as that price is below $8.93, we're saying yes. Wait a minute. It's a sunk cost. It's not relevant. It's a sunk cost. 100 units, $5 a unit. Do we take it, yes or no?
No. No, yes. I was looking at 437.
Because if it's a sunk cost, you're going straight right here. And you go, oh, 100 units, $500, divide by 100, that's $5 a unit. It's less than that, sunk cost, you just compare. You're going to increase profit by $6.90 for every unit. You're paying $5. You're taking it after you try to negotiate it down. You're taking it.
So would you